Hi, and welcome to another example on L'Hopital's rule. And in these problems, we're exploring the more challenging application of L'Hopital's rule. You should have already watched the explanation in examples 1 and 2. All right, so if I attempt to evaluate this limit when x approaches 0 from the right, what's going to happen here is I'm going to get 1 plus sine of 0, which is 0, to the, and cotangent of x. In order to evaluate that cotangent of 0, remember that cotangent of x is equal to cosine x over sine x. And as we approach 0, the numerator is going to go to 1, and the denominator, remember we're approaching 0 from the right, so sine x is going to get closer and closer and closer to 0 as x gets closer and closer to 0. So this is approaching 0 from the right, so this is going to be infinity. So our result here is going to be 1 to the infinity, which again, this is bad. This is an indeterminate form for which we cannot apply L'Hopital's rule. Now, anytime you have problems where the function that you're taking the limit of has an exponent, or an x is an exponential function, or has an x in the base and also an x in the exponent, we want to apply the logarithmic technique. So here's how this works. We're going to take our function and we're going to say y is equal to our function. And then we're going to get the exponent down, and the way we do that is to take the log of both sides. Once we've done that, we can apply the limit to each side independently. And what we're going to do now is we're going to look at this side and we're going to evaluate the limit again. So we've already done this part, the cotangent of x, if we're evaluating the limit as x goes to 0 from the right, is going to be infinity. This part turns into 1, and we have to apply the natural log of that. The natural log of 1 is 0. So again, we get something that's bad. This is again an indeterminate form for which we cannot apply L'Hopital's rule. So what we need to do is we need to look at our function now and see if we can force a fraction to occur. Now, the first and most obvious thing I see is that cotangent we can put into the denominator, and in the denominator it would turn into tangent. So let's rewrite this with the cotangent in the denominator as a tangent instead. Okay, so if we look at this limit, we've already evaluated the numerator. This is going to be the natural log of 1, which is 0. And if we evaluate the tangent of x, that's going to be the reciprocal of the cotangent that we did here. And if we think about what happens to this as x goes to 0, we're going to get 0 over 1, which is 0. So this becomes 0 over 0, which is good because, makes us happy, because now we can apply L'Hopital's rule to this limit. So we're going to do exactly that. We're going to look at the numerator, apply the derivative, look at the denominator, apply the derivative to get L'Hopital's rule. So let's do that. When we take the derivative of the numerator, we get 1 over 1 plus sine 4x, but then we have to apply the chain rule, which is going to be cosine 4x, and I'm going to put the times 4 here. So we get this wacky fraction, and the derivative of tangent x is secant squared x. This may look a little bit messy, but let's go ahead and plug in 0 for x and see what happens. If x is equal to 0, the cosine of 4x turns into 1, so I get 4 upstairs. Sine of 4 times 0 is 0, so I get a 1 in the denominator. And the secant of 0, remember secant is 1 over cosine. So 1 over cosine is going to be 1 over 1 if x goes to 0, and if we square that, we're going to get 1. So this result is 4. So that's good. Here's what we've got. We have just figured out that the limit as x approaches 0 of the natural log of y equals 4. So let's go back to the beginning. The original problem we were trying to figure out was the limit as x approaches 0 from the right of 1 plus sine 4x to the cotangent of x. We know that we called y. So these two things are equal. We're going to rewrite this in a different form, and we're going to call e to the natural log of y, which is essentially equal to y. Now, we know what this equals as x goes to 0 from the right because we've got it right here. We're going to substitute that back in, so we know that the limit as x approaches 0 from the right of e to the natural log of y is equal to e to the fourth. So this is the answer to our very original problem. I know this is a little bit complicated. We're going to do one more example. Make sure you're taking notes, and we'll discuss this in class as well.